we can change it to this forum discussion, okay? The idea around this forum discussion is that all of you can contribute, you can ask questions, you can answer questions. Please don't be quiet, otherwise it's going to be quite awkward. So, yeah, we can start.
Well, I can break the ice here.
Please do so.
In a quantum computing session, we talk about the future of quantum computing, but what about the future HPC? No future. It will be full quantum.
Yeah, something that I brought into my presentation was exactly that in Petrobras view, many are bringing that, oh no, but why you are investing in HPC? Because nowadays we have cloud, should we really rely on investing and purchasing all these machines here? And exactly in the presentation, the message that I brought was that, yes, we will keep evolving the HPC because when we go to cloud, first, they don't have the knowledge about the applications that we have. They don't know to do that in a proper way or the most efficient way as we are doing, optimizing that application, because what matters is performance. And second, it's the cost. The cost is much higher than we are doing just for ourselves. So I don't know exactly, your question have many dimensions, but one dimension is HPC will continue as an on-premise for many other players, and at least for us in the industry of oil and gas, yes, and it will keep growing, at least in my perspective.
Yeah, the trends that we see nowadays from our side is that on-premises cluster, it's the primary focus for HPC, okay? But we see a lot of attraction on moving some workloads to the cloud as part of a cloud busting capability. So having something, so if you do the math and you do the total cost of ownership, and you need a certain capacity just for meeting some peaks of needs, this is so expensive. But if you have the ability to load those expectations, to load that spends on local capacity, and then you use the cloud just for meeting those peaks of requirements, then cloud bursting makes a really valid option. Moving everything to the cloud when you have an ongoing need for HPC, it's bloody expensive. Even though if you use spot pricing and so on, so still not a viable solution. We are talking about very HPC focused workloads, obviously. Yes, please.
So I agree that HPC has been facing a lot of challenges in the last decade, and we have seen the cloud era or the evolution of cloud changed a lot of stuff. Even HPC had an impact on HPC. And that's where we started arguing about this conversion between HPC and cloud. And this has been done different ways. So we are trying to bring this automation to HPC, and we try to make it as easier as possible and bring new researchers to HPC. And so I've been working on it in the last decade. Now, one part of why HPC, I believe there's like an interesting future for HPC, because cloud alone will be just missing parts and pieces, and HPC will always be missing parts and pieces, and that's very important that none of them will be a complete and perfect solution. That's why we'll be completing each other. Now what I can see, there's another, let's say another step is coming in, which is AI, and that's becoming closer and closer to HPC. So we're expecting to see AI as important as cloud, as important as HPC, close to HPC. Because now, think about it, what we can see these days about the quantity of data running around ChatGPT or any AI solution available, you definitely need these big machines to be able to manage these. The amount of data is enormous. We are talking about thousands of petabytes of stuff, and there's no or exabyte. So the entire internet will be available for the AI, and that's where the HPC will play a big role actually in the future of the AI, and that's what we're expecting to see. As NVIDIA used to call it, NVIDIA and AI, they have been targeting AI as a future for them, and I believe they were right, and that's what we're expecting to start seeing HPC centers and AI. So they are going to be tagging AI next to each name.
Yeah. For me, imagine for me the future or what we are facing, it's I would say a mixed approach and how easily we can combine both worlds. So in our company, we realized that cloud only was not a solution, and mainly our production model is really based on a big machine on premise, but we are still being heavy users of cloud for more smaller problems. For me, what it would be nice is all these tools that are appearing, and we did not have time to test, to use it. It's really to make the convergence of both services in one place, because right now we are treating both of them separately. We have things in one cloud and we have things in the on-premise. And for example, 2 days ago, they told me, developments that I did in the cloud are not working on the on-premise and how I do it. So for me, another step beyond would be to have a central place, not only for resources, but also for the storage and so on, where can I work on both kinds of resources for the users, quite transparent to see if you want to run in the cloud or you want to run in on-premise, and make the both worlds work together. But I don't see that one will take over to the other.
I wish for the future of HPC, to your question, to be more diverse. Happy to see at least women here. I remember HPC KP in the like 4 or 5 years ago, and maybe it was just Anna. So I'm happy to see more and more women here. But to the topic at hand also is HPC in the future is composable. I would say that's, I stole your answer. But yeah, HPC is composable since we are now talking about this mix of cloud and on-prem and also AI and HPC. For me, a very interesting use case for this mix is climate change, right? There are a lot of things that we can do with AI for climate change, but also at the end of the day, climate change is just matrix multiplication, right? Like vector adds and like very low level Fortran code will always be the good, like the best thing for climate change. So we need composable HPC such a way that we can very quickly configure a cluster to be AI and then turn that over to a HPC cluster that is optimized for like Fortran code, all in the same machine. So HPC is composable to me.
So I would like to make the distinction between the traditional HPC that most of you here are more used to, with MPI, large MPI applications and running on thousands of cores, and the new trend for compute resources that are just available. So I'm just thinking about Jupyter Notebooks, RStudio, so the data analytics kind of workload that it's not the traditional HPC. Users are not looking for performance. They are mostly looking for availability and explorability of their work, right? So I don't know exactly what is the future of HPC in this sense. If we cannot make HPC more user-friendly with the introduction of portals or this flexible compute, I don't know exactly if we are just condemning HPC to the very specific use cases of large applications, while the cloud or other computing platforms then become more user-friendly and globally available to all the other kind of resources.
Yeah, for me, regarding the debate about the on-premise or public cloud-based or something like that, for me, it's just a consumption model. And in fact, for any one of you that work in a supercomputer center, I mean, a so-called generic supercomputing centers such as BSC or wherever. In fact, those are service providers for the community. I mean, no researcher has his own supercomputer in his office or at home. So it's about a consumption model. So either the so-called public cloud is relying on the service providers named as that, such as AWS or Google or whatever, or Oracle Cloud. It doesn't really matter. I mean, if the problem is about cloud bursting, about being able to submit jobs to wherever resources are available, in fact, it should be feasible also with the on-premise private clouds that we already have in place. For instance, I have met many customers of mine that are asking me about, I mean, they're asking me for a job, so to say, for customers. So yes, I need users to use my facilities so that I can justify the budget that I'm asking for. So because believe it or not, some of the mid-sized to small supercomputers are underutilized. So if it's about cloud bursting, okay, let's provide the community with the tools, the proper orchestration tools to do this cloud bursting and use the existing resources in many supercomputer centers, many universities, many small research departments that may have maybe a 100-node cluster. And let's not be that underutilized. And maybe the underlying infrastructure, it can be, why not the public cloud, AWS, whatever, but it should be transparent to the end user if we are able to provide them with the right orchestration tools and the availability of resources. And I'm also, I agree to Carlos, that sometimes, yes, it's not about how fast my job can run, but well, what available resources do I have? How many jobs can I produce at the end of a year? Not for one single job, and maybe the speed of each individual resource is not that important. That's my take.
If you look at all the HPC facilities around the world, so the trend has been changing, evolving over the last few years. Back in the time, there was a need just for a workload manager and a cluster file system. That's it. SSH, command line interface, whole time, and you do run the analysis, right? But nowadays, the users are more and more demanding. They are asking for Jupyter Hub, Jupyter Notebooks. They are asking for RStudio. They are asking for HPC portals that they can use the Internet Explorer. They don't need to change. It looks like a better desktop-friendly kind of approach, and that lead to new technologies like Open on Demand and so on, which is a magnificent piece of software, and we are contributing a bit on that as well. And the thing that I'm trying to say here is that this new trend, it's here to stay, and if you are not providing this kind of services, you are kind of left behind. And that's the reality. That's the new trend, and embracing this, it's key.
So just to comment on a few of the points that people have made. So I come from a center that has 100 nodes. I'm currently involved on the analysis side, so I'm a user. But I am working towards the systems administrator side, and I know that the systems administrators are currently struggling with an underutilized HPC. And I also see that some of the sources of data, the vendors of the machines that produce the data, are drifting very quickly towards cloud-based solutions that edge out our HPC. So they won't allow us to do processing of the data generated by the machines that we buy on-prem. They won't license us the images that they spin up on AWS to run on-prem, even though we already have the machines to do it. So this is a challenge for our system administrator to try and set up systems that we can send this data up to the cloud and then pull it back down, having to pay the egress cost ourselves from the S3 bucket. And there are a couple of hurdles that we have to get over. I don't think this is going to be something that's pervasive across all of the different data sources, since there's many different types of data being generated in all these different, I don't think astronomical data will ever be, you know, closed into this cloud-based system, kind of like locking you in. But it's something that we see as a trend. The vendors of these machines might be forcing you into the cloud infrastructure.
Just to come back a little bit to the talking about the user interface. So like you were saying, right? Unless you're offering things like Jupyter Hub or Open on Demand or something like that, you're probably a little bit behind the curve. These are first-class services in some of the, especially in the big HPC centers like CSCS and JSC, and there's an awful lot of development going on in that space. And you should really be aware of what's happening there as well. So that things like the way they do visualization in Jupyter Hub in places like Jülich, not many people are doing it like that. I don't know how many people are aware of how they do it, but it's really worth it. Like, I would really like to bring these things into projects I'm involved in. But it's hard. You need to transfer these things a little bit. And things like, well, I'm going to talk about this easy software stack, right? But this is about moving software around. So you talk about, in your case, of having to move data, right? Because you're forced to do this. You can't use, you have to upload to S3. There are other approaches to how you analyze data, right? And I'll show this today, that you can move your environment. You can have the same environment in many different places. And these are interesting projects that people are working in now. And because technologies have advanced, like this stuff, some of the stuff we're doing now wouldn't have been possible 10 years ago, say. But now you can have really, really fat UCX. You can have UCX that supports all of the interconnects that are out there, or libfabric, or both, right? Because basically you only care about the MPI layer, and it supports both, right? So you can have really fat builds of everything. So you can have transferable executables, and there are tooling to even give you independence from the MPI implementation, right? So things like, what's it called again now? MPI trampoline, right? I've used that. Very, very good for C. Doesn't work so well for Fortran, because unfortunately the Fortran standard and the MPI standard, they conflict. And so it creates a bit of a difficulty when you want to have one of these trampoline libraries to do something like that. But there's some very interesting technologies that do allow you to have mobility of your environment. You can have an executable that will work in multiple environments. And you can also, in some cases, if you use something like MPI trampoline, you can take the MPI implementation that's on the host that they ship and support with the system, and you can inject that into your stack. So there's a lot of interesting stuff these days that might change how things look in the future.
Just to bounce back, thank you for the idea. But just to clarify, if we as a service provider of genomic data, for example, are generating data on this machine that then uploads this to the vendor's portal, where they perform some pre-processing of this data, and then if we want to run say like a portable executable, I know Nextflow allows you to generate workflows that you can easily port between your HPC and Amazon, but in that case, you still have to pay for the computing that happens on the cloud. So as a center which has just purchased 100 nodes and has the infrastructure and hardware to run all the workflow in-house, they have to then pay for it to be run on the cloud just so that they avoid the egress. So I think we get stung either way. Is that correct, or maybe I misunderstood your explanation?
I think that it's about the technology underneath. So yes. So in your case, it's pretty terrible the situation that you are now. So not sure how you end up in that situation, but I think that what Alan was trying to say is that there are other protocols, there are other mechanisms to share data and everywhere you go. Okay, so it's not just about. So probably if you have this massive data set that potentially you need to use, if you want to use it on premise or on the cloud, you have to have a complete copy of that thing in one side or the other, right? And then you can perform the simulation or you can perform the analysis. The reality is that if you expose the cluster file system on a certain region, if it's fast enough, you don't need to access to the whole lot. You're going to read the files and you're going to read a portion of those files. So there are clever ways to get access to that, that data without transferring the whole lot to the other side. So there are many opportunities there that technologically speaking, they can achieve the same thing. And what Alain is going to explain in few minutes is the beauties of CERN BMFS. But yep, there are other ways to do that as well.
So I have one more comment here actually, but not about this discussion. It's like, so the discussion started about the future of HPC, you know, and from what we hear, we did not hear any suggestion. Maybe only he mentioned that we need HPC to be different, to change its shape, you know, dynamically. And I think this is one of the suggestions just about that will be helping in HPC. And I think we already, and I wanted to answer him because that's an interesting point actually he raised. So we already implementing that actually. So now we don't have anymore this static, huge HPC machine that you have a scheduler and you are running just big jobs. Definitely we're always trying to convince users that run it in an MPI way, no way for a single job, otherwise go to a smaller cluster, we can do this job. But we need always to parallelize the code. We help them to, you know, scale the code with a number of processors, number of nodes. However, what we recently are implementing on this new machine is this platform as a service itself. And that's integrated with an HPC machine using a high-speed interconnect, really high, up to 400 gigabit, which is slingshot from HP. And there we have this multiple clusters, or we call them V cluster or bare metal. And these are dedicated for customers, for project. And this is following this integration with the cloud where we can do this platform as a service. And this is where we allow customers, even we are going beyond only just offering this cluster, we are also creating a multiple LANs for even a customer LAN could be used on the machine itself. And that's where we are making this diversity, where we're making all these changes to be able to get what's required and avoid losing customer and jumping to the cloud because they can do whatever they want and here it's not allowed. So I think this level of diversity and changes in HPC is needed and it's becoming required, and that's where we have to catch up before it's becoming too late.
That's usually, well, that's the main reason I believe containers have been really successful inside the research community, because you can do whatever you want inside the container, and then you can bring this package to the HPC facility and run it. So that's the beauty of it. You don't need to be root in the cluster, but you can get a lot of benefits of managing your own Docker container as it is.
I just want to add for what you just said, that as a user, I don't care where my data runs, where my code runs. I want to have my scripts, if I have one, running as fast as possible, as cheap as possible. I don't care if it's cloud, HPC, or whatever. So what I see is an integration, a diversity and integration of the systems to have my analysis done yesterday and with the least cost as possible according to what are my resources, because it's very different from a researcher point of view with a small group that they don't have the fundings to set up an HPC or even run massive analysis on the cloud. So if I can have an environment where I can just upload my data and what I want to run on my data, I'm happy with it as a user point of view. Of course, we are on the other side, so we have to see what happens, and there is different levels of user. But in the biological science, what we want is to have the data analyzed yesterday and as cheap as possible. I don't care if this is cloud, if it's the Kubernetes cluster, if it's an HPC, if it's a server in someone's desks.
You need to add one point to what you mentioned, because you want it also to be easy to deal with.
Yes.
And that's exactly what will bring you the
A nice user interface will always help.
Yeah, to answer maybe to comment your comment, to comment Square. This is basically, I think about that like low and offer. I mean, offer and demand. This is depending on the resources. This is depending on whether it could be commercialized or not. And this could be, I mean, linked to jurisdiction. So the way you use data, the way you extract data, and if it's convenient or not, this is maybe more ahead of like commercialization or like massive use, and so the prices will be lower. Otherwise, I mean, to like propose like a kind of store that you can choose which data you need for which time, it's like more slightly commercial to me. And right now, maybe I think that these kind of technologies, maybe you have to educate first the end user and to make it commercial. I mean, I don't know if it makes sense.
Okay, just quick comment. I'm happy to say that I'm happy that I said diversity is the future of HPC, because it's half of the answer to like what you just introduced. HPC, as he mentioned, was built 10, 20 years ago for like, oh, we know we are going to have a physicist that knows how to write Fortran, and his MPI is going to utilize the entire cluster, and the entire cluster was designed for that, like just that. And that was HPC 20 years ago. Today, we have clusters that need to be utilized by biologists, chemistry, data scientists. That is a new way of doing computation. So we cannot build clusters just for like the physicists that know how to build Fortran and MPI. Right? Like we need to build clusters that can mutate for different users in the same location. Because like if you see DOE clusters in the USA, they were like built for like just, I don't know, like very specific physics, like, I don't know, like nuclear physics. Like if you try to research something different from nuclear physics, oh, no, it won't run because the RAM is configured because blah, blah, blah. Right? Like that is the old school HPC. New school HPC needs to mutate depending on the workload. And diversity would get us there, right? For the portals and UX, like when you go to places like ISC, right? Like, oh no, just do everything in Linux and Beam. Don't use IDE because that's so. Or I'm too good to use anything that is not Beam. Diversity is the way to break that, right? Like I feel like a lot of the things that we do bad in HPC is because it's like a 99.9% men realm. And once we start introducing diversity, and diversity will get UX, diversity will get better user interaction, diversity will get us to these new portals, and diversity will also get us to more scientists using HPC without having to become HPC scientists, right? Like we want biology people to use HPC and get back to being biologists. That's what we want.
So I could agree with the last part, but definitely HPC has been all for all kind of science for decades, from physics to astrophysics to math to all these. Hello, yeah. So for all these kind of science, it's not true that it was only for physicists and it was only for the most experts. I don't agree with this. However, I agree. Yes, we need more users for HPC. And that's where we started at the beginning, saying that we started a lot of initiatives, actually, to bring a cloud close to HPC, not to go too close to the cloud part. And that's where we are starting looking at automation. And that's where we are trying to do the part of offering HPC as a service, as a platform as a service itself, where we have all this variation. We have seen a lot of new customers, new users from different fields of the science coming that we never seen them on HPC machine. And we have also removed some obstacles that's related to, I remember when in 2010 or 12, if your code doesn't run up at a threshold of 32 nodes, you are not allowed to run on the machine. So all of this has been removed as an obstacle. And we are making the HPC machine as closer and easier to customers, where we guarantee for them the ease of access, speed that you cannot get it in the cloud, it really as fast as latency as microseconds, where a network, we was talking about 1 microsecond ping pong between two nodes. We want to guarantee that actually to users. Get her results as of yesterday and have an access and guarantee that data is there and it's not somewhere nobody knows where, and that it's saved for her. That's all of this will just get a researcher said, okay, I'm happy to be in this environment and have to be in working on HPC because what I need is there and I get my results fast.
Yeah. So maybe what we, and I agree that we need to make HPC more open and elastic, I would say. So I really like your concept of this platform as a service. But maybe what we should start doing is stop calling it HPC. So HPC outside our community, it's a scary thing, right? HPC has been scary for scientists because it had a high barrier of entry for the last decades, at least. Now we're trying to lower that, but we're still calling it HPC. We can call it elastic compute. We can call it however we want. But it's no longer the classical HPC. Maybe we need a better term to define these new compute capabilities that we're trying to build to allow our scientists to do their research, right? Because it's no longer focused on the high performance, or not, that's not the main focus anymore. The focus now is to make the resources available as fast as possible to the scientists. But as I mentioned earlier, the scientists don't care that much about how fast their code runs on a single run. They just want to get as many results as possible, right? Especially biologists that are the new coming, or data analysts. They have very little background on computing, computer science. So you will always find people doing very stupid things from an HPC point of view, right? But it's their way to get things done as fast as they know. We can always help, but we cannot be behind everybody's shoulder telling them how to do things the best way. So.
We are not losing access to memory, CPU, and scale. However, we want to add things to us. So that doesn't mean that we have to lose our identity. It's HPC because you need an infrastructure that's scary from the power, from the cost. You need a machine that costs hundreds of millions. So all of that, it has its identity. However, we need to add to it, what's needed for other research to accommodate more people in it. Doesn't mean that we have to lose our identity.
Look, I'm going to explain you a story. I like usually to explain these kind of stories. In the bioinformatics world, so I remember a PhD student that was running quite a massive job in the cluster back in the time when I was in the user support, okay? We did the numbers. She was filling up the cluster quite severely. And then we did the math, and we realized that she needed like more than 3 years of runtime using the 80% of the complete cluster at that time to complete the simulations that she was required to publish the paper, that paper, okay? Then spending time with that particular researcher, we realized that we could improve the code that was originally designed to run in parallel with MPI, but on a desktop computer. I ported to a cluster side, to a world-class kind of a code. And certainly, it ran 80 times faster. It doesn't mean like a huge speed up 80 times faster. You look at NVIDIA benchmarks and you see 300, 400, 1,000 times faster. It was just 80. But rather than 3 years, it turned out to be 2 weeks. So performance is not that important when you are looking for interactive. And this is, I think, that most of the biologists and life science are looking for. But when you are looking to get the results on a lifetime, kind of, probably you need to do something else. You need to put an effort in that. And that's where HPC, it really matters. And having someone behind you, backing you in this regard, it makes a huge difference in terms of speed up in the research, in the discovery, and the success at the end. And by the way, that person ended up publishing in Nature, and so it was a pretty successful thing. So it was a pretty good case study. Okay, there were more.
It's a silly thing, but I couldn't keep quiet. I just wanted to say that biologists are not newcomers to the HPC. Just to remember that Michael Levitt and Martin Karplus won the Nobel Prize, I think it was 5 years ago, for some jobs they did back in the 60s and the 70s, running in actually creating the world of computational biology. So that's it.
So just on that point in the story, I think that's probably one of the places where the incentives are very clearly bifurcated for HPC and for cloud, where for HPC, you want your users to be running things as efficiently as possible. And so being proactive and reaching out to users and seeing what they're doing, asking what they can, asking them how you can help is going to increase the efficiency of your cluster and availability to other users. Whereas in a cloud environment, why would they help you? They want you to use as much of their resources as possible because then they charge you.
That's the point. So that's the money. Yeah. So running not efficiently, that's can mean kind of okay for the end user, but what about the financial officer in your company? If run this into the cloud. Cloud is, yeah, please go. No problem with that. But yeah, when you put the dollar value in there, you see a huge difference. So we have a kind of a monitoring dashboard that gives you the dollar figures, and this changes completely the mindset of the researchers when they see, wow, this is the CPU time, but oh, that's the dollar figure. So it's massively different.
Yeah, I want to chime in a bit as one of these old school physicists, astrophysicists doing a traditional HPC on big systems. And it's a bit worrying that nowadays it seems like HPC clusters are more becoming like capacity clusters, offering 10,000 nodes that are built to run single core or single node jobs of maybe Python code that's not so well optimized, because that's what the scientists want to do. But the question is, wouldn't it be more worth it to build either a separate cluster that's optimized towards these workloads, maybe with a cheaper interconnect or with cheaper hardware that can do these things, do the capacity compute, or advise these users to proper cloud services that can allow them to scale up to 10,000 nodes? Because I'm okay with if there's many new ways to access an HPC system, have a Jupyter notebook running everything and having GUIs for everything. But it's important for us that do these or that did these large simulations that they can still access the resources they had before. So HPC should still stay HPC. They can get new capability, but it shouldn't just become only this new capability.
Yeah, to that point, like the comment that I was about to make is around ChatGPT. Now that you mentioned, there is a nice article, like it's just a blog post that criticizes how instead of optimizing their code, they just threw money to that, right? Like instead of making whatever is underlying of ChatGPT fast and like good, like Fortran optimized code, they just threw more money and bought more GPUs to get it done. So it's like they use capacity clusters instead of HPC clusters. And for me, like going back to the initial question of future HPCs, we need to like sit down a little bit and optimize what we have instead of just throwing money and, oh, let's buy more CPUs and more GPUs because we don't want to spend a couple of weeks making this code run better, right? Like HPC is not all about hardware, it's also about software. And I would say for the past 10 years, we kind of forgot about that, and we just start like throwing hardware to problems instead of like sitting down and saying like, with the hardware that I have, how can I optimize that?
Mm-hmm. Just a very little addition to that. Yes, exactly. So let's use what we have in a wise manner, because there are many underutilized systems all over the place.
I wanted to comment something that was appearing before now about the user experience and the resources and all this. And I, as a developer of a workflow manager system that we are running in the cloud and we are running HPC, what I like about what we can do in cloud that we miss in HPC, that maybe with Flux at some time it will be possible, we can do things like, because we know our users, many times they run the same kind of tools. So we are doing things in cloud like deducing which is the best memory allocation, the best CPU for that process. We know that process is running this method. We know that this method, it's working in Graviton. We can run only one process in Graviton, the other process in another microarchitecture. We can do these kinds of things in the cloud. But we cannot do this in HPC. The user needs to know which are the good queues for each job, and they have to configure all this stuff. We cannot automatize this in the HPC. For me, this is the main problem currently of the HPC, that you cannot put a layer in the middle of a tool that gives usability. So the end user, it's a biologist or even a physician, I have seen also, another even more that they do more strange things even. But they don't need to know. They don't need to know that this tool that they are running, it's running better in Graviton or in that microarchitecture. They don't need to know. We can know this for them and change it when it's run. And we cannot do this in HPC automatically.
I would like to do a comment about what you said before. So chucking more money to get a bigger capacity cluster to run whatever you need to run. So that works on a very specific kind of software. So assuming that you have an embarrassingly parallel kind of approach, you can add more and more money, you can add more and more nodes, and then you can achieve the linear scalability that you're looking for. But when you have a problem that have some dependencies, you cannot do that. You need to optimize the code, to run it faster, or you need to find more suitable capability to run that code for you, to run it faster. So this case that I was exposing before, having this running 80 times faster, I could add more and more nodes, but it wouldn't work because the scalability, top scalability was around 20 cores at that time. So it was impossible to get through that. So there are some situations that having more compute capacity, it's not a working solution. And this points to the second discussion. It's about user awareness of how to utilize the platform, how to select the platform. So this is huge, okay? How many users have you seen, I'm going to submit this job using 1,000 cores? Well, maybe your code is able to scale up to 16 cores, and you're underusing the other pretty much 1,000, or asking, yeah, I don't know how much memory is going to consume this code, but I'm going to use 100 gigabytes, just in case. And then the cluster slowing down, no jobs getting through because this cluster starvation going on. So we see this on a regular basis. And we did something to identify those situations, to identify those users. We need to talk, okay? But that's the reality. And when you have a local on-premises cluster, this is expensive. When you do that on the cloud, it's bloody expensive. So it's, yeah, so this technology awareness, knowledge awareness, and platform suitability awareness, it's really, really key. Coming for you.
So I wanted to make a comment about what you mentioned. It's like, yeah, it's interesting discussion. And I agree partially with you that that's true. We don't have this layer. Okay, first because most of our HPC machines, they are homogeneous. We don't have this variation of architect and on the same machine itself. That's one maybe of the disadvantages we had, so we not thought about this kind of variation between the platform itself. There's some intelligence of some of the applications where we have this pre-allocation of memory, where we can implement in the application itself, and we know that this will go to this part of the memory, so we can save some time and give some optimization. But I think this is another suggestion, actually, which could bring benefit to HPC if we have like this let's say, preparation on the code where we can, let's say, based on the code itself, you know where it could be ending up. If you have like a layer where we can see that different platforms we have in the center, and based on what the application could be just redirect to one place or another, where we have this centralized part, which is, I believe, we don't have so far. I have never seen any research center or HP center has this kind of workload. But that would be just an interesting suggestion. Thank you.
So thank you so much. I have been told that we are. Yes, let's do a last one.
Okay, sorry, I know I've had the mic several times, but I just wanted to comment on one other perspective. So we've been talking about all these things, but we haven't talked about how resources are allocated inside of institutes, companies, and funding models. So a lot of times when we decide to buy more cores, when we decide to buy more hardware, that might be a budget decision that's made at the end of the year. And depending on the bureaucratic processes inside of an academic institution, cloud might be more or less favorable. I don't know what the market forces are like looking forward, how this is going to shape this distribution between HPC and cloud. But I know in the case of that vendor that I commented before, they're leaning heavily into cloud because that brings more income in for them if they can lock you in. I don't know if the funding sources are going to have a preference in this, depending on if it's a public or private institute or a company, but I don't know, just a different perspective.
Okay, so yeah, I have been told that we are at the end of the session. I think that there's a lot of conversation that needs to emerge from here, but we don't have enough time to cover everything. That's why we have this forum in the HPC KP portal. So maybe we can try to move the conversation over there. Okay, so we are doing this one every year. It could be nice to do it every week or every month, but it's really, really hard. So so let's now we can have a really quick break. Okay, I'm not sure if we can get coffee over there. It looks like, okay. Yeah, okay, so let's have this coffee break, and then we can come back and join the workshop. Thank you so much.